Okay, now let's do our area of regular hexagons. We're just going to focus on regular hexagons for this, but this is also 9.2 area of regular polygons. But we're going to focus on the regular hexagon. And that's a hexagon with 6 congruent sides and 6 congruent angles. And let's talk about some different parts of this right now so that it'll be a little easier when we start working on it. We have the center of the figure, which is a point that's equidistant from each of the vertices. So that means I can draw segments to each one of the vertices. Each one of those segments should be the same length. Now when I draw those segments, I wind up with a certain number of triangles in there. We did a very similar thing with when we were finding the area of an equilateral triangle, we found 3 triangles inside there. We drew from the center to each of the vertices. For this one, we're going to have 6. 1, 2, 3, 4, 5, 6 of them. So 6 triangles this time. And if you remember when we did equilateral triangle, we divided 360 by 3 because there was 3 triangles inside, and we found that those central angles were 120 degrees each. For this one, we'll do 360 divided by 6, 360 degrees divided by 6, and that's going to be 60 degrees. So each one of those central angles will be 60 degrees. But just like when we did our equilateral triangle, when we found the area of that regular figure, we're going to draw an apothem down the center. And so that apothem is going to divide that 60-degree angle into 2 30-degree angles. The apothem is always forms a right angle with the side, and so 90 and 30 is 120. 180 minus 120 is 60. And so again, I have a 30, 60, 90 triangle. It's just kind of flipped from the one in the regular triangle that we did last time. And so for every hexagon we do, it's going to turn out the same. We're going to have a 30, 60, 90 triangle, and this will be our short leg, and this will be our long leg. And of course, this will be our hypotenuse. So it's always going to turn out the same with a regular hexagon, and so we're going to focus on those. And the formula is still going to be just like we use with equilateral triangles. Area equals 1/2 apothem times perimeter. 1/2 apothem times perimeter. All right, so let's look at a problem. Let's try one. Let's say we have a regular hexagon, and this regular hexagon has a side length of 4. Let's say it has a side length of 4. That's the regular hexagon, so each side is 4. Now when we draw our apothem in here, when we draw that apothem is going to go right down the center of that side, and so that's going to be 2 there, that side. It's going to cut that 4 in half. Let's keep that in mind. Okay, so let's see. We got our formula for the area of a regular polygon is 1/2 apothem times perimeter. And we can already find the perimeter. We know the sides. The side length is 4. There's 6 sides on a hexagon, so 6 times 4 would give us the perimeter of this figure, and that's 24. So I have my perimeter is 24 units. Right, so far, so good. Now we just need the apothem, and we'll be set. All right, so I drew my apothem already, and if you remember, we're going to draw our triangles here. And if you remember from just a few minutes ago, we said there was going to be 6 of them, and each one of those central angles were going to be equal to 60 degrees, because we did 360 divided by 6, because there's 6 triangles in there, so each one will be 60 degrees. And the apothem divided that 60-degree angle in half, so this is 30. And this is 60, so we have a 30, 60, 90 triangle. So let's take that out. Let's take that triangle out. let's take this triangle right here out. And let's see what we can get from it. We already know this side here is 2. We know this is a 30-degree angle and this is a 60-degree angle. And so this is my short leg. I want my long leg. I want that long leg there. That's the apothem. And so I know the formula says that the long leg should be equal to the short leg times the square root of 3. So my long leg, which is my apothem, should equal to the short leg times the square root of 3. All right, so there's my apothem. That was easy. Apothem, 2 times the square root of 3. So I have the perimeter, I have the apothem, and I'm ready to plug those into my formula. Area equals 1/2 apothem, 2 times the square root of 3, times the perimeter, 24. Now, right now I can multiply that 1/2 times 2 and I get 1. So area equals 24 times the square root of 3. We just have that square root of 3 left and that 24 left. So 24 times square root of 3. Let's call that units squared. Okay, let's say that we have, let's do another one. Let's say this time we have a, let me get my pen back. Let's say this time we have a hexagon. And instead of knowing the side, a regular hexagon, instead of knowing the side, let's say this time we have the apothem. This time we already know the apothem. Let's say that it is 6. So my formula, area equals 1/2 apothem times perimeter, and we already know A. We already know the apothem, it's 6. Now we just need the perimeter. And we can plug those into our formula. And so we're going to do the same thing we did with all these regular figures. We're going to draw our triangles here. Find each one of our central angles, each one of these angles. There's 6 triangles there. That's 360 divided by 6, which is 60 degrees. So I know each of those is 60 degrees. I know my apothem divides that 60-degree angle in half. So again, that's 30, and that's 60. And so let's pluck that triangle out. Let's work on that triangle separately. So we're taking that triangle out. We're working on it separately. So that's 90 degrees. My apothem we already know is 6. I know this is 30 and this is 60. And so that apothem is my long leg. It's opposite the 60-degree angle. I want my short leg. And so let's find that. I want my short leg because if I have that, I can find the length of the whole side, and then I'll be able to find my perimeter. So let's find that short leg. So since I have the long leg, I'll look at the long leg formula. The long leg, 6, equals the short leg times the square root of 3. I want to solve for short legs, so I'm going to divide both sides by the square root of 3. And so my short leg equals 6 divided by the square root of 3. And I'm not allowed to have a square root in the denominator, so I have to rationalize the denominator, multiply top and bottom by the square root of 3. And so 6 times the square root of 3 is 6 times the square root of 3. And the square root of 3 times the square root of 3 is just 3. And those will reduce. So now I know that side is 2 times the square root of 3. And that's helpful because if this is 2 times the square root of 3, if this is 2 times the square root of 3, then this right here is 2 times the square root of 3. And the whole side is twice that, or 4 times the square root of 3. And so that means each one of the sides is 4 times the square root of 3. So it's easy for me to find the perimeter. The perimeter is 6 times 1, 2, 3, 4, 5, 6. 6 times 4 times the square root of 3. And 6 times 4 is 24. So I know my perimeter is 24 times the square root of 3. I know my apothem is 6, and I'm ready to plug them into my formula. Area equals 1/2 apothem, 6, times perimeter, 24, times the square root of 3. And let's see, I know the I know that 1/2 of 6 is 3, so I got 3 times 24 times the square root of 3. And let's see, 3 times 24. 3 times 20 is 60. 3 times 4 is 12. So that's 72 times the square root of 3. 72 times the square root of 3, and then we'll say that's units squared since we didn't give it any unit of measurement like inches or feet. And that's it. That's the area of a regular hexagon.